The unit circle. So it's called a unit circle because it has a radius of 1 all the way around. So that unit, or 1, makes the unit circle. We can define 1 radian as 1 radius. So in this case, 1 radian is equal to 1, or that unit. The circumference of a circle, of any circle, is 2 pi r. The circumference all the way around, so that's the distance around. Imagine if you were to make a cut right there and kind of lay it flat. You could turn it into a line, and that would have a distance of 2 pi, or a little more than 6. In this case, our radius is 1, and so the circumference is 2 pi r. So this circle, if we were to take, this radian right here, this radius, and we were to wrap it around the circle, it would go to about here. That would be 1 radian. So we're taking this and going around the circle. It will go around that circle 2 pi, so a little more than 6 radians will fit around that circle. So the circle will wrap around 2 pi radians. So the distance all the way around is 2 pi. And that's in radians. So we could lay that out and we would find that that's 2 pi. So we can use this to kind of locate some of the places on this circle. So we know if all the way around gets us to 2 pi, that distance is 2 pi. That means that halfway around is probably going to be pi. So we can use a wrapping function to take a certain amount of radians, put them into the function, and see where on that circle it's going to end up. And we can use these as coordinate points. If we place this unit circle with the center right at the origin, this distance right here, all the way over to 1, we can get out a point. So we're going to input the radians, how far we're going to go around the circle, and we're going to output the actual point, the coordinate point. So for example, if we use for this wrapping function, we substitute a 0 in here. That means we're going 0 radians. So this distance is going to be 0, and we're going to end up right back here. So that's going to be the point 1, 0. The reason it's 1 is because this distance right here is 1, and it's 0 because I'm sitting right here on the x-axis. Now if we take the wrapping function of pi, pi radians is halfway around this circle. So if we travel 3.14159 that far, that many radians, we end up right here. Now notice this radius is 1, but we're looking at it on the coordinate plane, so that's in the negative direction. So this point is actually -1, 0, because I went in the negative direction that length of the radius. So this wrapping function, if we were to substitute pi radians in there, would give us -1, 0. So let's take a look at this wrapping function a little closer. So we're taking in a distance. We're taking in the radians that we've gone around, and we're outputting a point, a coordinate point. So we're used to seeing functions where we input one value and get out another value, but this time we're inputting, our domain is going to be radians, and our output's going to be a point. So our range is going to be actually a coordinate point. So let's go ahead and take a look at this. Let's label some of the important parts of our circle. So starting here with 0, we travel around the circle and we have an arc length of pi. So this length right here, if we were to straighten it up, would be length of pi. And then going all the way around, we get to 2 pi. Well, between 0 and pi, halfway, we know is pi over 2. So we know this is pi over 2 right here. And then if we continue down, we get to pi. In between pi and 2 pi is like 1.5 pi. But we usually leave it as an improper fraction. So 3 pi over 2. And that's the same as 1.5 pi. And now we can take a look at what this wrapping function does. So knowing that this radius is 1, when we move it all the way up here, we know this length is 1 as well. And so this point right up here that we're at is going to be 0 on the x, we're not moving anywhere on the x, and then up 1 because our radius is 1. So the wrapping function of pi over 2 radians is equal to 0, 1. Now as we move around the circle, we can see we're changing a little bit and then coming down to here to 3 pi over 2. Well, this radius is 1, but we've gone in the negative y direction. So we're still at 0 on our x-axis, and then down here, that point represents negative 1. So our wrapping function of 3 pi over 2 is 0, negative 1. Now the question is, what is the wrapping function of pi over 4? So pi over 4 is halfway between our 0 and pi over 2. So this is pi over 4. And we want to know what's that point. Well, we can tell we're getting less than 1 on the x-axis because we look right here. We know this is 1. We're less than 1 on the x-axis. We're also less than 1 on the y-axis, but where exactly are we? So what we can do is we can draw a reference triangle to help us figure out where we are. So if we can find this height of the triangle, we know how far on the x-axis we've come. And if we can find the height, we know how far on the y-axis, we've gone up. So this height represents my y-axis. This distance right here represents how far I've come on the x-axis. So if I can find this side length, that's actually going to be the x value of my coordinate point. And if I can find this side length, it's going to be my y coordinate. And so I want to really look at this triangle. This I made into a 90-degree triangle. And I'm wondering, what are those angle measures right here? Here and here. So I know this length right here is going to be 1. The reason it's going to be 1 is because it's a radius. So imagine this radius flipped up over here. And I know that's going to be 1. Now here and here, I really want to know those side lengths. Well, if you imagine, this is a 90-degree angle right here. So we have a 90-degree angle. It's our x and y axis where they're coming together. And here is halfway in between that arc. So this point is halfway between, which means those angles are half of the 90-degree angle. So this has to be 45 degrees. Well, if this is 45 degrees, then this also has to be 45 degrees. Well, now we have a 45, 45, 90, and we have one of the side lengths. It's the hypotenuse. It's not one of the legs, but we can use that to figure out this side length and this side length. So this is what we've got. And we know this side length has to be equal to this side length because it's an isosceles triangle. It's that 45, 45, 90. And I just used L for my length, and 1 I know because it's my radius that I flipped up there. So this is what my triangle looks like. So I know by 45, 45, 90 that this one has got to equal the square root of 2 times whatever length this is. And I don't know what length this is. Then I can go ahead and solve for L just by dividing by 2, to both sides by 2, by square root of 2. So divide this side by square root of 2, this side by square root of 2. And I get L is equal to 1 over the square root of 2. If I rationalize that, that's square root of 2 over 2. So this height is going to be square root of 2 over 2, and this length is square root of 2 over 2. So this is square root of 2 over 2. This is square root of 2 over 2. That makes this point square root of 2 over 2. You also could leave it in the without the denominator rationalized, so it would be 1 over rad 2. That's okay too. So my wrapping function then for pi over 4 is going to equal square root of 2 over 2, comma, square root of 2 over 2. Because that's a 45, 45, 90. Now let's look at the rest of the circle and go ahead and label these quarters over here. So here I've gone to 1/4 of this first section. So that's pi over 4 because this whole half of the circle is pi. And then I have pi over 2. And this one right here, I want to know what's between pi over 2 and pi. So I wonder what's there. And one method to do this is to just think in fourths. So this is pi over 4, 1 pi over 4. This is 2 pi over 4. That's the same as pi over 2. 2 pi's over 4. This must be 3 pi's over 4. So 3 pi over 4. And then this is 4 pi over 4. So 3 pi over 4 is in between here. And you can just change them all to fourths so you can see what's in between. So this is 4 pi over 4. Oops, let's write this. 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. 6 pi over 4, which makes sense because I have 3 pi over 2. 7 pi over 4. Okay, so now they're all labeled. Now if you think about it, each one of these is going to give us a 45, 45, 90 triangle. Only thing that's going to change is the sign. Over here, my x coordinate, this square root of 2 over 2, is going to be negative. My y coordinate is going to be positive. So this would just be square root, this one right here, the wrapping function of 3 pi over 4 would just be square root of 2 over 2, negative square root of 2 over 2, comma, square root of 2 over 2. The negative would be the x. And so let's take a look at that. So here I have all of them labeled with going through fourths. So all the way through 2 pi with fourths. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, and then 8. You can think of 2 pi as 8 pi over 4. And notice what's changing here. So the x value is negative because I'm on the negative side of the x-axis and the y value is positive. Down here, both the y and the x values are negative, so I have a negative square root of 2 over 2, comma, negative rad 2 over 2. Here, notice that my x value is positive, but my y value is negative. So now you can use these to find the wrapping function of 7 pi over 4. If we insert that in a wrapping function, we're going to get out this coordinate point. So let's take a look at how we can use the wrapping function if we wanted to keep going. Talk about a lot of radians, 10 pi radians. That's more than I have on my circle. So I'm going to continue wrapping around. So I'm going all the way over here. That's 2 pi radians. Another 2 pi radians, which is a total of 4. Another 2 pi radians. That's 6, 8, and 10. Notice I get back to the same place as I had for both 0 and 2 pi. So wrapping function of 10 pi is just 1 comma 0. So if we input negative pi over 2, notice we've been going in this counterclockwise way. This negative pi over 2 changes the direction. I want to go a total of pi over 2, but I want to go in the opposite direction. So when I go pi over 2, normally I go to here, but I want to go negative, so I'm coming back over to here. So that would get me to 0 comma negative 1. That negative sign just switches the direction. Wrapping function of negative pi over 4. Instead of going this way, pi over 4, I'm going this way, pi over 4. So I'd be right here. So the wrapping function for negative pi over 4 would give me rad 2 over 2, comma, negative rad 2 over 2. So I'm negative on the y-axis there. Now, here's an interesting thing to think about. Wrapping function of what is going to give you 1 comma 0. Well, there's lots of them here. I already see 0. I know 0 gives me that. I know 2 pi gives me that. And 4 pi would give me that. 6 pi would give me that. 5 pi would not, because if I went around 2 pi and another 2 pi, that would be 4 pi. 5 pi would give me negative 1 comma 0. So you can find infinite t's there, infinite radians that would give you that same value. Now if we have the wrapping function that gives you square root of 2 over 2 comma square root of 2 over 2, the obvious one when we wrap around, it's going to be pi over 4. So t would equal pi over 4 here. But also we could get that again. So the other way we could do that is we could go negative 7 pi over 4. So we could go all the way around Not all the way to 8 pi over 4, which would be 2 pi, but we could stop here. So negative 7 pi over 4 will also give me this output, this range value. So another way I could do it is I could go all the way around, so that's 2 pi, and then around just a quarter. So this would be the same as 8 pi as 4 pi over 2. So this is 4 pi over 2, but I want to talk about fourths, and so that'd be 8 pi over 4. So I have 8 pi over 4, that's the same as 2 pi, 8 pi over 4, plus another fourth. So that would be 9 pi over 4. And I could do it again. I could add another 8 pi to that, 8 pi over 4 to that, and I would be back here. So each time I go around and then another quarter, I'm going to have another value that gives me the square root of 2 over 2. So after we're finished with this, we're also going to add thirds and sixths. So make sure you get kind of familiar with just the halves and quarters of the unit circle. Another important thing to realize is that if you know the arc length right here, you also know the measure of this angle. So if this arc length is pi over 4, you can talk about that angle in radians as well. That would be pi over 4 radians.